Hello everyone, welcome to the chapter 5, which is a modeling the depreciation assist using the recurrence. So recently we finished the financial solve, and then now it's time actually we re- actually reviewing. If you got a chance in the end of the term 3, you can come back to have a look at it. The chapter 5, 6, and 7. Hopefully, I'm gonna be back on the right track because I've been lazy a couple of weeks, focused on the in school time. So today, what we're gonna do is we're gonna try to start 5.2 and then start with some basic fundamental part, which is first order recurrence relation. So first thing first, first order recurrence relation, which is the defining the relationships between the two successive terms. For example, we have previous term and we have a next term. So normally we say the first term will be u0, or you normally say v0, and sometimes a0. So first order linear recurrence relation can be writing as u0, which is a, un plus 1, which is capital R, which is they call the constant number to multiply your previous term, and plus the other numbers with constants. So let's have a look at the one example. So normally I would say first 5 term sequence, which is starting with a 1. Once you have that number, which is the showing you, which is like v0 equal to 1, and success terms increase by 2, which is each terms will be plus by 2. So first one will be v1 equal to v0 plus 2, or can we just say vn plus 1 equal to vn plus 2? So which is previous term adding 2, which is the next term. So next one will be, we see v1 equal to 3, v2 equal to 5, and v3 equal to 7, and v4 equal to 9. So which is 5 terms, which is always starting with v0 as the first term, second, third, fourth, and fifth. So recurrence relation, first order recurrence relation will be with this and this, which is you're always writing the first term. Another question which is we can using as the calculator. So first 5 terms defining the first order recurrence relation, which is vn plus 1 equal to 3, un plus 5, v0 equal to 2. So how are we gonna using that? Hopefully, most of you guys understand how to using the least and squares. So what we do is we start with first term. I say v maybe. The first term is equal to 2, so which is you're writing the 2 on the first line. Second one we start straight away equal. So if you type equal, that means next few lines will be equal to. So 3u, which is 3 times. Now it's important thing is like a1. What's a1 means? That means the first term. And then you will say plus 5. So they give you the next term straight away. Once you highlight this one, and then you press menu, can you see the data? And they're going to fill. So you fill for the next, maybe to the 6 or maybe to the 5. So 1, 2, 3, 4, 5 terms, and that will be your answer straight away. So normally I would say this is how you using as in calculator. So hopefully that kind of makes sense. And you can use that for the first order recurrence relation all the time as the least and squares. Or you can use this other way, which is you just tap in 2 and just tap times 3 plus 5. But sometimes you have to calculate, like to follow the orders, right? So you say 1, 2, 3, 4, 5. All right, some example questions. Let me just quick clean this one and then show you guys how we're gonna find the answer. Clearly we already say the answer is D, but yeah, let's see how that happens. All right, first thing first, recurrence relation. All right, the value of A3, which is we know, which is the fourth terms, 0, 1, 2, 3. So now what we do is we can just substitution the new terms, which is I say A. The first one equal to 3. Second one equal to 2 times B1 and plus 4. So next one equal to 10. And then because that's A1, right? So then we say fill. Let's see what's the V3 A3 set, right? A3 set. So which is we're gonna find A2 equals. So which is A2 equal 24. So A3 will be equal to 2 times 24 plus 4. So then this answer will be equal to D. Does that make sense? Hopefully. And then the next one, first 5 terms, 2, 6, 22, 86, and 342. So we're gonna find out the recurrence relation. Once we have that generates the sequence could be. So now we're gonna try to figure out what's the difference between 2 to 6 and 22 and 86. We could just doing the elimination. So which is what we do is we try to figure out what's the difference between the first one. So we can say the P0 always 2, so A, B, C, D, E will be right. But next one, let's say a 6, so which is 2 plus 4 equals 6, that's correct. 2 times 2 plus 2, that's correct. 3 times 2, that's correct. And 4 times 2 and 1 is 2, that's correct as well. So then we can say 2 to 6 is correct for everyone, for every answers. Now what we do is we go into 6 to 22. So first one I'll go 6 to 22, that's not correct. And that's not correct as well. 3 times 6, that's not correct. But this one is correct, and the next one is not correct. So clearly we can say the D will be the correct answer. Hopefully that kind of makes sense again. And then now what we do is, don't worry, let's try to figure out this question and why that equal to E. So first thing first, we always start with the recurrence relation. First thing first, let's have a look. First 4 terms recurrence relation equal to first 4 terms recurrence relation. Okay, so start with 2. So if you have 0 and 1, that's not correct straight away. So C and D and E. Now what we do, same idea as we do is G. Start with 2 and 3 times, okay, it's 2. So start with 2 and then we're going to 3 times C1 and plus 1. Forgot about something is called equal, so that's why sometimes you forgot that. And next one, you click the fill, you go into 3 terms, that will be 2, 7, 22, 67. 2, 7, 22, 67. So the kill, you can say it's E. And so please using the calculator all the time. If you can understand that, that will be awesome. So fingers crossed you understand all these ideas of first order recurrence relation. I'll see you guys next time.